The fourth solid principle we will be looking at is dependency inversion principle, which states that your classes should not depend on concrete classes, but rather on abstractions, meaning on abstract classes and interfaces. The goal is to protect the core application logic from breaking when external tools or data formats change. Let's look at an example that violates the dependency inversion principle. Assume that we have this process class with a calculate total method that takes in a concrete class, a SQL database as a parameter, and here is our SQL database that has one method, fetch prices. Assume that this makes a connection to a SQL database, fetches all the prices, and then returns them as a list of integers. Then the calculate total takes the SQL database as a parameter, calls fetch prices to get the prices, and then computes the sum of all these prices and then returns them. This is in violation of the dependency inversion principle because calculate total depends on a concrete class, a SQL database. What if you would like to change the data source from a SQL database to a MongoDB database or a web API provider? In that case, we have to implement a new calculate total that takes a MongoDB or a web API provider. So bottom line is for every data source, now you have to implement a separate calculate total method that takes in that specific implementation of the data source, which is cumbersome. Let's look at the actual code. Here's my SQL database class with fetch prices method. This is my data source. And here's my high-level module process with the calculate total method. As you can see, this method is taking a low-level concrete class SQL database, and this is the violation of the dependency injection principle. So remember, the dependency injection principle says high-level modules should depend on abstractions, not on low-level implementations. And this is depending on a low-level implementation, a concrete class. And so this is the main method. I am calling the calculate total method of the process class by instantiating a SQL database object and injecting this database object into the calculate total method. Remember, this is called dependency injection. So if I run this thing, I'm going to get the sum of all the values, the values that the SQL database provides, which is 10 plus 20 plus 30, which is 60. To fix this problem and have our implementation comply with dependency inversion principle, we are going to first define an abstraction called price provider with one method, fetch prices. Then we are going to have all concrete data provider sources to implement this price provider interface, which is what we are doing. We have three concrete classes, SQL database, MongoDB, and web API service. Each of them implement the price provider interface and of course have to give an implementation for fetch prices method and just give a list of values that they provide. Finally, we are changing the interface of calculate total. So instead of having a specific concrete class as a parameter, now this calculate total takes an abstraction, which is price provider, which means that I can inject any implementation of price provider as a dependency into this calculate total. So now our high-level module process depends on abstractions, not on concrete implementations. Here is the actual code. This is interface price provider with one method, fetch prices. And these are my concrete data source providers, SQL database, MongoDB, and web API service. Each of them implements price provider and provides an implementation for fetch prices. This is my high-level module with calculate total that depends on an abstraction now and thus satisfying the dependency inversion principle. And here's my main method. So I am calling process.calculate total. And each time I am instantiating one concrete data source and injecting that object as a dependency into calculate total. So the first time I make the call, this is going to take the data from a SQL database and calculate the total. The next time it's going to take the data from MongoDB object and calculate the total. And finally, the data is going to be coming from web API service and calculate the total. And let's run it. So as you can see, these are the three different sums. You can now see the benefits of having our high-level modules depend on abstractions because now I can provide any future price provider implementation as a dependency into this calculate total function. and I do not have to change anything on this calculate total method at all. This is called open closed principle. So calculate total is open for extension and closed for modification, which leads us to the fifth solid design principle, the open closed principle.